Some of the topics I have not dealt with yet. I'm also facing shortage of time. So what I'll do is I'll just take some of the important discussions, important topics which must be discussed as far as classroom lecture is concerned.
So
And जहाँ पे भी theoretical course, yeah,
start the recording, sir.
yeah. Oh, yeah, 1 second. And wherever the theoretical portion is needed, I'll tell you which reference to go for that, and you can read from there. Okay, before we start, let me just ask you: do you want to write your term end examination on R, or you want it to be a pen and paper test? How are you comfortable?
Sir, R will be okay. I don't know about others.
So sometimes R is not comfortable for Mac users, so if possible, pen and paper is better.
Sir, are you
Yes, a
asking?
pen and
Mac
paper is
user,
better.
Sir, are you asking for a time test, or are you asking
yeah.
like we get a few hours assignment?
No, I'm talking about term end examination. Let us say if we take it on R, obviously it will be easier for you to handle that. Plus the time taken, or the duration of the test will be longer, but you will not take that much time to complete the assignment. So, and it will give you a better hands-on experience of working out with these models on the software. And that's why we are precisely having all these classes on R. So I would have preferred if you would have gone for R software,
Sir,
because pen and paper.
assuming
Again, yeah.
At the end, we have to do these things in R, right? Like we have to solve this model and all. Like we can't do this in pen and paper. That's why I wanted R.
Correct.
Otherwise, it depends on all of our students actually.
sir, I assuming that the R test happens with things we are familiar with. I think a lot of us would be fine with that. But if the exam is something like the assignment that you gave, where we have to learn a lot of new things to apply it,
Yeah.
then I think that would be very uncomfortable for the exam, because we have no scope to learn anything in the middle of the exam. So that is our main thing. If it is things you're familiar
No.
with,
Yeah, so you will be tested on what we have discussed in the classes. Obviously, I'll not give you term end examination where I have not discussed things at all. So that will be taken care of. But I leave it up to you guys to decide whether if you're comfortable in giving an R, then it will be a great experience for you all as well.
okay,
Yes,
sir.
sir.
Would you let us also have some time so that we can discuss amongst ourselves and get back to you in a while? Our CRs probably.
हाँ, एकदम you.
Yes, Setu, you were
You take
saying
your
something.
time,
I'm so
no
sorry I
issue.
cut you off.
Yes, sir. Even I'm comfortable with
Yeah,
R.
Setu,
The
please.
only concern, the similar concern like Neil was that in the last assignment, when we were discussing about different tests and different procedures used by different people for the assignment, it was quite different. Like I did not do many tests for different assumptions to be proved or not. So if there is a specific syllabus, then it will be better that what we have learned, we are applying that.
Yeah. Syllabus will be definite, and that's what I'm announcing it right now. That whatever we have talked about in our lectures, that I'll ask. Nothing
And so
else.
regarding the time, will it be like we will get a 3 hours time only, or will we get a little extension because it's like we are going to do it on our and we can like what will be the time
I
if
think,
we
Shania, I think solving questions using software should take you lesser time. So duration,
yes I
obviously,
just
it will be of
asked.
3 hours, considering it will be a
Okay,
60 marks total. Yeah.
okay.
Yeah. So as usual, the duration of the normal duration of term and examination, that will be of 3 hours only. My only see the thing is, like, after this, after the session gets over, again you'll you solve anyway all the examination mostly on pen and paper. This is the only subject, you can say, or course where you can or just try solving these things on software, or इसको मतलब approach करने के चक्कर में you'll also tend to learn new things as well. So that is a precise purpose, and I leave it up to you. You take your time, and जब भी आपको comfortable लगे, you just inform me so that I'll also set questions accordingly. Is that fine?
Okay, sir.
Okay, all right. So let us just discuss some of the things which are left as far as linear regression model is concerned. Obviously, I'll not be able to talk all the things, but जो भी important होगा. And apart from this, discuss the dummy variables. So what I'll do is जो भी आज हम discuss करेंगे, and I'll try to send you the syntax for dummy variables. I'll also discuss in brief about dummy variables, the logic or the interpretation about these qualitative variables. और जहाँ तक examples और understanding की बात है, तो I'll try to send those R syntax files to you guys. So precisely in this lecture, what I intend to cover is, let me just present my screen. Give me a second. Yeah, can you all see the screen now?
Yes, sir.
Yeah, okay, all right. So precisely what I want to cover is, the possible problems with the error term, and the thing about heteroscedastic error terms we have already discussed. Autocorrelation will automatically get covered when we start discussing the time series equation, because mostly the errors tend to be correlated with each other when you have the data which are typically of time series. The problems associated with multicollinearity, I'll go with the theoretical details in this lecture. So I'll talk about multicollinearity, and in very brief about variance inflation factor and condition number, which are precisely one of the methods to detect the presence of multicollinearity in the model. Possible remedial measures for multicollinearity is you calculate variance inflation factor for all those variables, and जिनका ज़्यादा variance inflation factor होता है, उसको simply you try and remove that variable out of the model. This is one of the trial and error method by which we try to correct the model or free the model from the multicollinearity problem. Again, let me reiterate the point that multicollinearity is more problem which is of a degree. So जब तक आपके variables perfectly related नहीं होते, then if they are perfectly correlated, what happens is that your identification does not hold anymore, and that's why you're not able to uniquely identify or estimate the estimators which are required for linear regression model. So as long as the degree in which the variables are correlated is tolerable, तो वो researcher to researcher पे depend करता है. And I had also discussed about this in very brief in my last lecture, where I told you that mostly variables tend to be correlated when you talk about multiple linear regression model. Because what you're trying to do is you're trying to estimate a causal relationship between a variable which you call as a response variable and several variables which you define it as an explanatory variable. So these variables tend to be correlated because you have taken them out of the same population. The problem only happens when they are perfectly, or you can say when they are perfectly collinear with each other. In that case, we were discussing the matrix method to visualize the problem of linear regression. In that case, you can understand that the columns of the data matrix, all columns are not linearly independent of each other, and that's why the problem of multicollinearity becomes that of a degree, where if the variables are perfectly correlated, that's where you have a problem. So we'll talk about multicollinearity and the possible way to detect multicollinearity, that is mostly through variance inflation factor. So we'll command using the example of variance inflation factor. Think about the combination of hypothesis which we had discussed a while ago. So I'll skip the t-test of significance, because when you just report the summary of regression results, you are automatically presented the t statistic for each of the variables, so you can easily find out the individual test of significance. The problem happens when you talk about joint hypothesis, or when you have one when you're not dealing with a simple hypothesis, but when you have series of hypotheses which are linked together. So mainly we'll talk about linear restrictions, and that's where we had discussed that when you have more than one simple hypothesis joined with each other, then you are not able to just run a t statistic, and that's where your f test or f statistic comes on. Then we discuss about the predict command, that is इसको भी हमने example में कुछ classes में cover किया था, where we had talked about how the confidence interval for predicted values or expected values of the response variable. So we'll just try and see this predict command. Then some of the possible modifications to the data that we have, that is how do we actually talk about when you somehow scale the data, or you apply logarithm to the data set, or you have or you have interaction terms in the data set. So mostly talk about some of those with changing, or you can say scaling of data, so scaling of data. And then finally we was reset test, and this is mainly functional misspecification. And one more topic will cover of your omitted variables. So let me just just summarize what we have discussed so far. So miss specifications in your linear regression model by talking about error term.
Sir?
Then
Sir?
we have yeah.
Sir, sorry to disturb you, but your voice is breaking a lot. So from the
Yeah.
prediction point, we couldn't hear anything.
Can you hear me now properly?
Yes, sir.
Is it clear now?
Yes, sir.
Yes, sir.
Okay, all right. So what I talked about is that where the example that I learned in our previous few lectures, where we tried to predict the average fitted values using some of the
Sir, your voice is
hypothetical values of the
breaking.
experiment. So that's again my voice.
Yes, sir.
Yes, sir.
Just give me a second, guys. Just a second. Or is it same?
So we couldn't hear. What did you ask?
Can you hear me now? Can you hear me now?
Yes, sir. No, sir, we can't hear you at all.
Correct. Then just give me a second. Hi, is it better now?
Yes, sir.
Yes.
No, not yet. ठीक है अभी?
So it's better.
Okay, all right. So just interrupt me whenever you face the same problem. I told you the net is really irritable because it's been raining a lot at my place. Anyways, talking about that, learn to use the predict command where we linear regression model run किया है. उसका one of the major purpose is to predict the future values on the basis of the model that you have run. So we'll try the predict command about various scaling of data or various modifications that we do in the explanatory variable, either real terms or logarithmic terms, or we are talking about running a regression parameterized variables. So this is how to write all such commands. This is what about scaling of data. And then we talk about functional misspecification. This is when you have a problem associated with incorrect functional forms for linear regression model. And one specific test that we'll discuss about is reset test, and that is regression equations specification error test. And then we talk about the omitted variables. All right, so let us go ahead and discuss about each of them one by one. So let me talk about omitted variables, or in the broad heading, let me just write it as possible problems with the data matrix. The entire specification of linear regression model, if you remember, depends on linear relationship, the way you population. And so इनमें जो भी problem आएगा, that will cause, or that will to run a diagonal for your model again and again till the time you find the best and perfect model, or not perfect model as such, but so the possible problems with the data matrix is, or can be, you can have inclusion of irrelevant variables. Now, what exactly this inclusion of irrelevant variables is? Suppose, the population regression model, actual or population regression function is beta naught plus beta 1 x1 plus beta 2 x2 plus, let's say, only this term. So in the actual population regression function, you have only two explanatory variables. Let us say, this is how the actual population regression function looks like. So the possible problem of inclusion of irrelevant variables, I'm sure that you, by the heading, you understand that this is a problem associated with including too many variables which are not required. So as far as the consequences of inclusion of irrelevant variables are concerned, the consequences are not that severe. In that sense, your OLS estimators still remain unbiased. But does this mean that this does not cause any problem or cause any problems which are very serious? So if you just think a bit deeper, you'll understand that though the OLS estimators remain unbiased even under the problem of inclusion of irrelevant variables, but having too much variables has a problem of its own. First of all, जितने ज़्यादा variables include करोगे, it means as many number of parameters you have to estimate, so you are worried about degrees of freedom. Second thing, the variance covariance matrix of the OLS estimators, you understand that when you have more than one independent variables present in the model, you also have in the denominator the correlation coefficient term amongst the explanatory variables. So automatically, inclusion of irrelevant variables definitely has some detriment on the variances of the OLS estimators. So as far as the unbiased property of OLS estimators are concerned, they remain unbiased. That is the in the presence of or more than necessary variables which should have been included in the model. So as far as the unbiasedness property of OLS estimators is concerned, they remain unbiased. There is no problem as far as biasness is concerned. Agencies of the OLS estimators definitely get impacted. But again, mostly inclusion of irrelevant variable is not that concerned, and most often researcher whosoever is carrying out the research, after reading sufficient theory behind the model, most often such problems definitely they do not encounter. That is inclusive, they do not include irrelevant variables, and that's why this problem also does not get that attention, because it is not that serious in nature.
Sir,
The exact opposite of this problem is, yeah.
Sir, it may be a small doubt, but sir, won't inclusion of more variables make it more accurate because we can paint a more holistic picture of the line?
No, you see why. Irrelevant variables क्या है? Irrelevant variables mean, suppose the actual model is this, and what you did is, instead of this,
So
what
your voice is
the
breaking.
researcher or anyone did is, again,
Yeah, after me he's doubt, your voice started
is it
breaking.
here? अभी ठीक है?
हाँ सर, अभी ठीक है सर.
So irrelevant means what? Suppose this was the actual population regression function that is actually correct, but instead what you did, or let's say what Mihir did, is to include additional X3, which he thinks should be included in the model. Number of variables present, holistic of the true relates to be talked about. Now, first thing that you have to understand is that irrelevance means what? We actually do not know, because the regression function actually is unknown to us. What we do is we first have a population regression function. So irrelevant means क्या हुआ कि ये जो x3 है, all these beta naught, beta 1, beta 2, beta 3, they all are partial regression coefficients. Meaning what? This beta 1 gives the impact or influence of one change in x1 on the average expected value of y, keeping x2 and x3 in control. Similar interpretation for beta 2 and beta 3. But when I say that one variable is irrelevant, what it means is, in this case, let us for the time being assume that this x3 is irrelevant, means must be equal to 0. And this you can easily test, using the two models. Build one model you can run excluding this beta 3, one model you can run including this x3 in the model, and then you can compare the two models. Now irrelevant means what? Is that when you control for already in the model, what it says is that now x3 no longer explains any movement in the expected value of y. Meaning what? कि x3 का हो सकता है, x3 का हो सकता है, there is some sort of correlation with the response variable, but when you already take x1 and x2 explicitly in the model, what it means is that x3 now no longer has a separate partial influence on the expected value of y. That's why it is called as irrelevant variable. So irrelevance comes by the interpretation that when you already have the explanatory variables in the model, in the presence of those included explanatory variables, the explanatory variable loses its own partial significance with respect to y. Now, coming or answering to the second part of what you asked is, it is nowhere written that having more number of variables actually increases the holistic picture of your model. First of all, why is this true is because when we are talking about R square, which is one of the common sense statistic to find out whether a model is accurately fitting for the data or not. But R square is a function which does not guarantee you an increase if you go on increasing more number of explanative variables in the explained sum of squares. So agar x3 irrelevant hai, it means what? Now include x3 explicitly in the model, it does not lead to it in the explained sum of squares. You see, why you keep on including additional variables in the model is to have an additional increase in the explained sum of squares. Because ultimately R square is based on this ratio that out of the total variation in Y, the explanative variables that you have in the model, how much of that explanation actually gets explained by the explanative variables in the model. So x3 relevant hota even under the presence of x1 and x2, x3 somewhat contributes to increase in explained sum of squares. But the precise reason why it is called irrelevant is because it does not lead to any increase in explained sum of squares. So what it does, it leads to increase in the number of parameters to be estimated. Now, the number of observations or the sample size itself is limited. So if you have more number of parameters to be estimated, as many number of observations you lose, and that's why you're concerned about degrees of freedom. So irrelevant variables, that's how it creates a problem. But the problem is not that much of great consequence, and that's why we do not discuss it a lot. इसको टेस्ट करने का सिंपल तरीका यही है, आपका null hypothesis होता है that beta 3 is equal to 0, and alternate hypothesis will be that beta 3 is not equal to 0. If you are able to reject the null hypothesis, what it means is that x3 is not an irrelevant variable. Basically, what it means is that even under the presence of x, when you keep in control of x1 and x2, x3 definitely explains some movement of y. Your null hypothesis, what it means is that x3 is irrelevant variable. In that case, you simply remove the variable out of the equation. That is what it means, that even if this variable is not included in the model, it does not impact the fit of the data by the model that you have run. Is that clear, Mir? Can you hear me? Is that clear, Mir?
Sir, yes, sir, it's clear.
Sir,
Okay, all right. Yeah.
sir, what if
Haji.
X-ray also has
Yeah.
a high correlation with the variables?
What if x3 also has a correlation with the
variables?
with these variables, right?
Yes, sir.
With the explanative variables. See, even in that case, what it generally means is, see, ultimately, what matters to me is that x3 must explain the movement. Now, x3, x1, x2, they are correlated with each other. They definitely will be correlated with each other, because you have to understand that when you explicitly include x3, what you're saying is that in presence of x1 and x2, which you have explicitly included in the model, x3 has got some partial influence on y. So as their explanative variable, they'll definitely be correlated with each other. But if x3 does not lead to any increase in explained sum of squares, it does not serve any purpose for us as far as explanative variable is concerned. इनके correlation तब matter ज़्यादा करेगा when x3 been included in the model, but you forgot to include that x3 in the model. Why such or why so? Because when X3 actually is relevant, and somehow either due to measurement issue or due to the unobservable factor, you're not able to explicitly count X3 in the model, what happens is that now that X3 becomes the part of the error term. And in that case, there's a problem associated with errors with the regressors. In that case, it creates a problem because it itself was a relevant variable which should have been included in the model. But अगर x3 irrelevant है, meaning which कि अगर x1 x2 को आपने already count कर लिया अपने मॉडल में, so x3 को explicitly include करने की जरूरत नहीं है. So some amount of correlation of x1 x2 with the x3, if it is an irrelevant variable, it does not change or it does not lead to any detrimental consequences as far as the model fitting is concerned. It will only be detrimental if x3 was a relevant variable and you forgot or somehow you are not able to include that explicitly in the model, which is exactly the problem of what is called as omission of relevant variables. Now, it is exact opposite of inclusion of irrelevant variables. Now, abhi tak you would have understood that no matter how elaborate you build your model based on theoretical justifications, it is almost impossible for a reason to include all the explanatory variables or at least relevant explanatory variables which should have been included in the model. And it is not due to the incompetence of the researcher, but there are many factors which contribute to omission of relevant variables. Precisely one of the major factor which contributes to this unobservable variables. Something like if I'm trying to estimate a causal relation of wage with respect to education, that is, how wage earned by an individual depends on the amount of educational qualification that he or she has. A common sense judgment would be that wage just does not depend on the educational attainment of individuals. If that would have been the case, then all the individuals who have the same educational qualification should have wage also depends on some other explanatory variable. And let us say for the time, yeah.
Sir, your voice was breaking. So could you repeat the last sentence you said?
Where did you? Where was I when you
Sir, I
heard
guess
me
you're
last?
talking about wage. You're talking about wage being dependent on the educational attainment of the individual.
Correct. Okay. So is my voice clear now, Abhi?
Yes, sir.
Okay. All right. So what I'm talking about is, let us say you're trying to talk about wage earned by an individual, and let us say you ran a model beta naught plus beta 1 educational attainment plus error term. Now this is a very simple linear regression model where this beta 1 tells you that by 1 unit increase in the educational attainment by individuals, by how much expected wage earned by the individual goes up. Now you dig deeper, you go into the field, and then what you notice is that if that would have been the case, then all the individuals who have the same educational attainment, let's say all of you are postgraduate, but is it necessary that all of you earn the same wage rate when you enter the employment pool? Not necessary. So let us say Meher comes up with an additional variable where he says that apart from educational attainment, what I also feel is that ability is one such variable which has a huge influence on the wages earned by an individual. Now, ability is one such variable which is very, very hard to quantify or even measure. It is unobservable. Similarly, if you're trying to estimate or if you're trying to find out a causal relationship between profits earned by a firm on various determinants, there might be some variables which you either are not able to explicitly observe, let us say something like organizational behavior or management ability of the firm. It also has a huge impact on the sales revenue or vis-a-vis profits earned by a firm. So when you have such variables which are latent variables which are not directly observed, such variables tend to be excluded from the model. So when you have exact opposite case of a variable is relevant. Now, why it is called relevant? It is called relevant because when you extend the model from simple linear regression to multiple linear regression, it is a relevant variable, meaning which that if you keep control of all other explanatory variables that you have included in the model, even when you take them in control, this variable which you have not included in the model, it explains movement in the variation of the dependent variable. So let us just try to build this theoretically and just have a numerical example, and then we go and run a R command on this, which is the problem of omitted variables. So let us say, hypothetically, that your original model is this. So in this case, this is a multiple linear regression model having two explanatory variables excluding constant. So here this beta 1 hat is what? Beta 1 hat measures how much expected y is going to change when there is a 1 unit change in x1 keeping x2 constant. Similarly, beta 2 hat explains change in the average value of y when x2 changes by 1 unit, keeping x1 constant. Now, instead of this, let us say a researcher ran this model. Now, this is a simple linear regression case where this beta 1 explains expected change in y when x1 changes by 1 unit. Now, let us look at this problem a bit differently. What is this beta 1 new estimator which explains movement in average value of y when x1 changes by 1 unit? Precisely is this direct effect of beta 1 hat due to x1 on y hat. So let me write it as beta 1 hat plus, since you have taken x1 and x2 explicitly in the model, what it means is that in this multiple linear regression model, apart from influencing y directly, x1 also has indirect effect on y through correlation or movements in x2. And similar explanation for x2 you can give as well. That is, x2 just directly does not cause movement in y, it also has an indirect effect through x1. So when you do not include this x2 explicitly in the model, it's thought of as beta 1 hat, beta 2 hat, and let us say call a new estimator which you call as delta 1 tilde. Now, what this delta 1 tilde is, this is the coefficient when you run a regression of x2 on x1. So let me write it here. Now look, now let us understand what exactly it means. So now if you increase x1 by a unit, there are two effects now. So if you increase x1 by 1 unit, it causes a change in expected value of y by this beta 1 hat times. So this is a direct effect. But whenever x1 increases by 1 unit, x2 also increases by delta 1 tilde time, delta 1 tilde units. And for each of such increase in x2, y hat changes by this beta 2 hat times. And that's why this beta 1 tilde, that is new estimator, can be thought of as exactly composed of these two parts. Where this is your direct effect and this is your indirect effect, that is change in x2 through movement in x1. Because ultimately this beta 1 tilde explains movement in the average value of y due to change in x1.
So could you repeat this point again?
Now you can see here. Yeah. Ultimately, you see this beta 1 tilde, what it does, it explains movement in average value of y due to change in x1. So this, when you simply take x2 out of equation, what it means here is that x1 just does not have an impact on y hat directly, but it also impacts x1 y hat through its correlation with x2. So in this example, what happens is that what we is called problem of exclusion of omitted variable. And this indirect effect, which is your beta 2 hat, this is called your omitted variable. Meaning what? कि अगर original model, instead of running this model, you ran this model. So ये जो beta 1 tilde है, now it either underestimates x1 or it overestimates x1. And that underestimation or overestimation depends on this, which is your beta 2 hat. And beta 2 hat, you understand, is the coefficient of the omitted variable. This delta is the correlation with the explanatory in the model. So basically, variable bias will depend on delta 1 tilde. So if you actually see my beta 2 hat either greater than 0 or it can be less than 0. Similarly, x1 x2 which can be greater than 0 or less. So these are the four possible cases which you can actually think. Beta 2 is positive. Correlation between x1 and x2 positive means what? When it, if x1 increases, x2 increases, x1 decreases, x2 decreases. So both positive, it means there be a positive bias. One of them positive, another negative, because it's a multiplication term. This will be negative. Again, this will be negative and this will be positive. Now, the only time when the exclusion of relevant variable is not that significant, that is, your OLS estimators still remain unbiased, is either when they are not, that is, explanatory variable and the omitted variable are not correlated with each other, or when
Sir, you're not audible, sir.
think logically why if your original model, am I audible now?
Yes, sir, but we lost you
Can you hear
for
me
a
now?
couple of seconds. Yes, sir, but we lost you in middle somewhere.
Where did you lose me?
Sir, you were saying something omitted variable, then we lost you.
Okay, all right. You see, if your actual model is, and instead of running this model, the researcher ran this model. Now, if this x2 is a relevant variable, what it means is that it should be explicitly included in the model. And when the researcher, either due to the unobserved part or due to his not able to anticipate that x2 should be included explicitly in the model, if you do not include this x2 here, what it means that this vi now contains this beta to x2. And if x2 and x1 are correlated, that is given by that delta 1 tilde, and if it is a relevant variable, it means the assumption of expected value of ui condition on the data matrix is equal to 0 does not hold. And it's a serious breakdown of the assumption. So exclusion of omitted variable leads to problem in unbiasedness property of the OLS estimator, and the bias that results from the problem of exclusion of relevant variable is called as omitted variable bias, and that depends on the sign of these terms, where the first term is the actual partial regression coefficient of the omitted variable, and the second term is the correlation coefficient between the explanatory variable which is in the model and the variable which has not been explicitly included in the model. This is what is called as problem of omission of relevant variables.
Sir, I have a doubt.
Now, yeah,
Sir, how do we exactly decide that
yeah,
which
go
variable
on.
is important and which variable isn't? Because it seems a bit discretionary on the part of the researcher.
No, you see, yeah, obviously, the theoretical understanding of the project automatically depends from researcher to researcher. Which variable is relevant and which variable is irrelevant? First of all, I told you that before running the model, before starting with the idea of the model estimation, the first thing that a researcher should do is to plot the graphs. And that's where scatter plot matters a lot. क्योंकि वो एक पहला स्टेप है जो आपको देगा कि कोरिलेशन बिटवीन द रिस्पॉन्स वेरिएबल एंड द एक्सप्लेनेटरी वेरिएबल्स कैसा है. If there is very low correlation of the explanatory variable with the response variable, then automatically it gives you an indication that this variable need not be included in the model. So that is the first step. Second thing is that what your theory says. If your theory says that this automatically, should be included in the model. That is, it explains the variation in the dependent variable that you're trying to estimate. Then obviously it becomes as important as it should be. So कौन सा variable relevant irrelevant है that you decide by plotting the graph, that is your scatter plots. And that's why this pairwise correlation gives you a nice indication of the variables, which variables should be included. I'll not digress that much out of this topic, but when you have large number of variables in your model or in your theory, let's say you have 50 number of explanatory variables, and the data set, let's say you have 1,000 number of observations, so the dimension of your data set is 1,000 times 50. Now in this case we are having a problem of too many explanatory variables, and you're not able to actually decide which variable is important, which variable is not. And in this case, plotting a pairwise correlation is actually very tough, because almost you have to draw a pairwise correlation of almost more than 1,000. 15 to 49 by 2, you can calculate it yourself. So in order to solve this problem, a method which used to be very, very popular back 10-15 years ago is called as, again, there are so many limitations of the model that now it has virtually ceased to come into actual experimental practice, but it used to be very popular. When you have large number of explanatory variables in the model, basically you run, or you have principal components, which is nothing but linear combination of all the regressors, and they are ordered according to the variance of the component. So that is just one possible way to actually find out कि actually क्या है कि आप अगर आपके पास बहुत सारे linear regressors हैं और बहुत सारे regressors हैं, तो you just find the linear combination of all those regressors. And there are many limitations of PCA. It gets automatically disturbed by units of measurement. Then sometimes it loses its economic or interpretation. So that's why it is no longer used by a lot of modern day researchers. But the nice way to start with, if you're not dealing with too many explanatory variables as far as your model is concerned, then you start with scatter plot of each of those variables against the response variables and amongst the explanatory variables themselves. So that is one way to start with your model. All right. So after the exclusion of relevant variables, that is omitted variable. So एक चीज याद रखिए that when you have problem of this exclusion of relevant variables, one possible method of resolving this is what is called as instrumental variable estimation, or IV estimation, which we'll discuss. IV estimation, let me just give you a heads up what exactly is instrumental variable estimation. ये basically, the name suggests instrumental variable. It means what? कि अगर कोई मान लो x2 एक variable है which you are not able to observe it directly, so what we do is we try to have a proxy variable for that. So अगर ability एक variable है जिसको मैं directly observe नहीं कर सकता हूं, so I'll have a proxy variable. Proxy variable means, the variable for which you can collect the information and which reveals characteristic about the unobservable variable. It's like the ability जो हमने example देखा था. Ability can be, let's say, a proxy variable for ability can be, let's say, your IQ score on a normal IQ test or an aptitude test. This is what companies do when they have their aptitude test. They actually just acts as a signal. and then you collect. So there are certain conditions of a variable to become a proxy variable, that is, it must be correlated with a variable which you cannot observe, and then it must be uncorrelated with the error terms, that is residuals in the model. So if it satisfies both the criteria, you run the normal regression using the proxy variable, and that works perfectly fine. Now, after having talked about the problem of exclusion of omitted variable, let us talk very brief about one other possible problems of the data matrix, which is your multicollinearity. Now, see, again, multicollinearity is a problem when you have the explanative variables perfectly correlated with each other. And where exactly you find this correlation factor in the linear regression model is in the variance covariance matrix of the OLS estimator. So simply, if you actually think variance of one particular OLS estimator is your, they are nothing but the elements on the principal diagonal of the variance covariance matrix of the OLS estimator, is your sigma square upon summation x, let's say xj square into 1 minus, this is the variance. So if you're talking about, bj hat, meaning which you're talking about the coefficient which is attached to the jth variable in the model. Let us understand this term. Sigma square is your, as familiar, the error variance, which is obviously not known to you, and that's why you estimate using sigma hat. This
Sir,
summation
sorry
xj
to
square is
interrupt.
nothing but summation xji. Yeah, again you
Could you
lost
please
my voice, Neil.
No. I just couldn't catch on with all of the variable, all of the in like alphabets and this thing. Could you please repeat those? I'm so sorry.
Yeah, I'll do. ये formula,
Yes, sir. Yes, sir. Yes,
right?
sir.
ये Neil, this is just based on this. First of all, ये लिख देता
Yes,
हूँ यहाँ
sir.
पे. तो है ना, तो जो भी आपके elements on the principal diagonal, they are nothing but variance of the OLS estimator.
Yes, sir.
ठीक है? Now
Yes,
sigma
sir.
square term is your error variance.
Correct.
ये जो
And now
summation
that is the
xj
inverse.
square, ये क्या है? Summation xji, ठीक है?
Yes, sir. Difference from, yeah.
That is jth variable का उसका deviation around its mean का sum of squares. चलेगा?
Yes, sir. Mm-hmm.
और ये rj square क्या है? It is the r square or coefficient of determination when you run a regression of xj on all other explanatory variables.
When xj is considered as the predicted one.
Predicted on all other explanatory variables in the model. That is, you precisely
All
run a
right.
regression of xj on all other explanatory variables in the model. ठीक है?
Okay, sir. So
यहाँ
this
तक
looks,
दिक्कत?
yeah, this looks like VIF का formula.
Exactly, यहीं से आता है नील.
Hmm.
Shall I go ahead and then then
Yes,
you'll
sir.
able
Yes,
to
sir.
understand?
Yes, sir. Actually, I got confused with the
ये
R
सारे
shape.
notations अभी for the time being clear है, ये क्या क्या है? ठीक है?
Yes, sir. Absolutely, sir.
ठीक है, तो इसको जब तुम when you expand this, जब आप x को in the deviation form लिखोगे तो ये सारे term आपको आ जाएंगे when you expand this. Okay, let us go ahead and just understand this. So actually आप देखो ये summation xj square is what? If you have n number of observations, it can be written as xji minus xj hat का square ठीक है। एंड अगर इसको मैं डिवाइड बाय n करूं तो ये वेरिएंस ऑफ xj भी हो जाएगा। सो इस होल टर्म को I can also write it as n times variance of xj. Guys, are you with me here?
Yes, sir.
Guys, are you all with me here? I have not done anything, just manipulated the variance formula. ये summation small xj square है, that is deviation का square. So I can write it in this manner. I'll take all the nth of all the n observations on the explanative variable xj, subtract the mean from all these raw observations, square it, sum it up. Clear?
Yes.
Yes, sir.
Am I clear? ठीक है? This whole divided by n will give you variance of xj. नहीं? नहीं?
Yes, sir.
Yes, sir.
है ना? Okay, all right. प्लीज रिस्पॉन्ड करो, अदरवाइज आई थिंक कि समझ में नहीं आ रहा है। सो दिस इस टर्म को मैं n टाइम्स वेरिएंस ऑफ x से लिख सकता हूं, राइट? अब तुम थोड़ा सा वेरिएंस ऑफ इसको आप हल्का सा मैनिपुलेट करो। सो दिस होल टर्म कैन बी रिटन एज 1 अपॉन n सिग्मा स्क्वायर अपॉन वेरिएंस ऑफ xj into 1 upon 1 minus rj. ठीक है? Guys, are you there with me here?
Yes, sir.
ठीक है? So ultimately variance of the OLS estimators depend on these four parameters. First is your n, which is your number of observations. Large number of observations will lead to lesser and lesser variance, which is good for the estimation. First thing. ये जितना कम होगा उतना बेटर है आपके एरर वेरिएंस के लिए, सॉरी ओएलएस एस्टिमेटर के वेरिएंस के लिए। ये जितना ज्यादा होगा वेरिएंस ऑफ एक्स, दैट इज जितना ज्यादा वैल्यूज, जितना ज्यादा डिस्टिंक्ट वैल्यूज होगा उस एक्सप्लेनेटरी वेरिएबल्स पे, उतना बेटर है वेरिएंस ऑफ दैट एस्टिमेटर। एंड देन यू हैव दिस फाइनल टर्म which depends on this r square j, where this rj square is nothing but the r squared or coefficient of determination of xj as a function of all other explanative variables excluding xj in the model. So ये जितना ज्यादा उतना ज्यादा ये डिनोमिनेटर कम होगा और उतना ही ज्यादा वेरिएंस ऑफ बीटा हाई होगा। And it is this last term, which is your 1 upon 1 minus r square of jth variable. It is called your variance inflation factor. Now, what it does? Variance inflation factor helps you find out if your model suffers from multicollinearity. वो कैसे? मैनुअल मेथड है, मैनुअल भी कर सकते हैं, और देयर इज दिस डायरेक्ट नाइस कमांड ऑन आर विच इज योर VIF. You can simply run this command on the regression results. It will give you variance inflation factor for each of the explanative variables. जिसका अगर मान लो जिस पर्टिकुलर एक्सप्लेनेटिव वेरिएबल का वेरिएंस इन्फ्लेशन फैक्टर बहुत ज्यादा है, व्हाट इट मींस दैट इफ आई टेक ऑल अदर फैक्टर्स constant just for the time being, it automatically means that this rj square is very high. Very high means ये जो explanatory variable है, when I ran this regression on all other explanatory variables in the model, a large portion of movement of xj gets explained by the variables in the model. And therefore, it poses a potential problem of what is called as multicollinearity. And so, you remove this particular variable from the model. Now, variance inflation factor के बहुत सारे limitation है. Theoretical portion, again, I'll ask you to refer to a textbook. You can read the theory behind that. But as far as running the statistical command using the software R is concerned, we'll just solve an example and try and understand, because this is the जो भी theory है और जैसे build होता है, that's what I've discussed. I'm really sorry, I do not have that much time to talk about the theoretical implication, but just understand that this has huge limitations, variance inflation factor, because units of measurement पे depend करेगा, आप explanative variables को कैसे combine कर रहे हो उस पे आपका r square depend कर जाएगा, तो बहुत सारी limitation है. That's why variance inflation factor should also be used with appropriate caution. That is, it should not be just relied upon to detect the presence of multicollinearity. बहुत बार हो सकता है कि अगर आप simply explanative variables को अलग तरीके से आप present करें, तो आपका problem of multicollinearity जो कि high variance inflation factor से दिख रहा है, that can be removed. So I'll ask you to refer to a good reference on this topic. So please read for the theoretical implications. But as far as this variance inflation factor as a method of detection of the presence of multicollinearity is concerned, it is based on this R square. It is based on this coefficient of determination of the explanatory variable against all other explanatory variables in the model. और अगर sufficiently high R square है, it means that R square क्या बताता है आपको? It tells you the ratio of ESS upon TSS. इस केस में मेरा dependent variable is xj. So if R square is very high, what it automatically means is that a huge proportion, a large proportion of xj gets explained by the explanative variables which have actually included in the model. So it definitely means that xj is correlated, or xj is significantly correlated with the other explanative variables in the model, and it will be better if you remove xj out of the model. But again, a word of caution that this conclusion should always come with this warning that what variance inflation factor tells you and what it does not tell you. That will be absolutely clear when you read the theory behind it. And why I focus on this? Because if you're asked such questions in your interviews, then you're able to answer them properly. So as far as the multicollinearity problem is concerned, it can easily be run by using the command variance inflation factor. Now what we'll do is I'll ask you to open RStudio, all of you, and we'll discuss, or we'll just run variance inflation factor and discuss about the problem of omitted variable on R. So I request all of you to switch to RStudio. Once you're done, please let me know. Ready, guys?
Yes, sir.
Okay. Do you all have lectures tomorrow at around this time?
Yes, sir. We have a microeconomics class from 5 to 7.
Monetary macro.
No, sir, microeconomics too.
Who teaches that?
So Kalki ma'am is about to start her sessions.
Kakli. You're talking about Professor Kakli Mukhopadhyay Setu?
Yes, sir, yes.
She started the lectures.
So your voice is breaking. What did you ask?
She has not yet started with the lectures.
No, sir. She just has a small portion which she has to cover. Rest of the portion was covered by Atri ma'am.
Acha, okay, all right, okay. Wednesday, Thursday, Friday, Saturday, Sunday. Guys, I need to take some extra lectures. Please let me take. Are you guys free on Wednesday?
Sir, what time?
Anytime, morning, afternoon, evening.
Sir,
Okay,
can I?
मुझे inform अपना time table and हाँ, with coordination with the finance CR, you know the possible timings चलेगा एक दिन का समय लो and so
Okay,
make it okay, thank you. First example that we'll do is for the omitted variable, and for this, I asked you to load the data set GPA1 from the package Woolrich. What I have to do is I have to load this GPA1. Guys, I hope also are comfortable in post.
So your voice is breaking.
Again, अभी clear है आयुषी?
So it's still breaking a little.
This better now? Can you hear me now?
Yes, sir.
ठीक है अभी? Right. So, just explore the data set just for the time being. Uh, All right. So run the regression of college GPA and test score and high school GPA. So just run that and report the coefficient results. So let me write regression. I can directly get the coefficient of what? Run the regression model of all GPA on and achievement test score, and that is GPA 1. Okay. So now if you
Sir,
run the
sir, we
REG
can't see anything on your screen, sir.
variable, it will
So we are unable to see anything on your screen, even if you're typing something.
just give me space. You hear me now?
Sir, your voice is breaking apart, sir.
Hi, is my voice clear now?
Yes, sir.
ठीक है, आप स्क्रीन देख पा रहे हो?
No, sir.
Not yet, sir. Yes, sir, we can now see it.
Can you see the screen now?
Yes, sir, we can see the screen, sir.
And you are able to hear me now properly? No?
Yes, sir. Yes, sir.
Yes, sir, you're audible.
All right. So in the case, see, I have loaded the one data set from the back. Then I want for regression. That is, I have ran the regression of college GPA on high school GPA, which is what we had done previous lectures as well. And by this COEF command, I can directly get the coefficient and its value. Is it still here? Guys, is it still here?
Sir, we lost you in between, sir.
Sir, your voice is breaking.
Sir, is there any possibility we could just continue this lecture later sometime because we're losing you a lot in between and it's becoming really tough to catch up.
Um, okay, okay. Just let me
Yes, sir.
try one more time.
Because sir, we've turned on the captions and tab jaake we're understanding a little bit of what you're saying because we're losing a lot in between. You're getting disconnected quite often.
Okay, okay. Just give me a second. Just let me try one more time, and if it doesn't work, then we can continue tomorrow. Okay? Just give me a second. All right. Can you hear me now properly? If it doesn't work, then we'll leave for today. We'll continue it tomorrow. Can you hear me now properly?
Yes, sir, we can.
अभी चल रहा है सही से?
Yes, sir.
Yes, sir.
Okay. All right. If गड़बड़ाता है, then we'll continue tomorrow. ठीक है? Can you all see this?
Sir, we can't hear you.
So we lost you.
Okay, then guys, let us discontinue today. We'll continue with this tomorrow. Can we start early tomorrow around 8:30? Is that fine with all of you? Can we start early tomorrow? Guys, can you hear me?
Yes, sir, just now.
Yes, sir, if you
Yeah.
want. We
Can we start at 8:30
yes, sir,
tomorrow?
we could if you want.
ठीक है, हाँ, so time. So we'll start our session at 8:30 tomorrow. ठीक है, 8:30 to 11:30 we'll have our session. Is that fine?
Okay, sir.
So 8:32.
Okay. 8:30 to 11:30. I've just preponed the session by 1 hour.
Okay, sir. Thank you.
चलेगा?
Chalega, sir. Thank you, sir.
Okay, all right. I'm really sorry.